What's going on, Math 10C? So we are on to 2.5, which is using the sine and cosine ratios. So last topic, we learned how to use and set up our ratios. We even learned how to find our ratios, find our specific angles using inverse sine or inverse tan or inverse cos. Okay, now we gotta remember how to manipulate these formulas in case we're given an angle. And say we have a hypotenuse, but we want to solve for the opposite side length. We got to know how to manipulate these. So these formulas are set up exactly like tan, like in 2.2, how we manipulated these. But it's good to refresh. So let's review how to. Okay, and here we'll solve for hypotenuse. So solve for hypotenuse. Okay, so let's say we have sine angle, and that equals opposite over hypotenuse. Okay, in this case, the thing we're solving for is on the bottom. Okay, if it's on the bottom, the first thing you need to do is get it on top. Okay, how do I do that? Well, to get it on top, I'm going to multiply both sides by hypotenuse over 1, because remember, what you do to one side, you do to the other. And then you can see that cancels out hypotenuse on this side because the same thing dividing each other just equals 1. And then on our left-hand side, you'll get hypotenuse multiplying sine angle, and that equals opposite. Okay, and again, we're trying to solve for hypotenuse here. So that means we have to solve for it. Well, what is sine doing to hypotenuse? It is multiplying, so we are going to do the opposite and divide sine by both sides because we're trying to cancel sine out on the left-hand side. What's going to happen is you have sine dividing sine. So now you have solve for hypotenuse. Okay, so that's a quick little algebraic review. It would be the same thing over on cos angle here. Okay, so you would end up getting, I would probably practice, but if you were to solve for hypotenuse, you should get adjacent dividing cos angle. Okay, and then you can go from there. Okay, so let's kind of show how to use this information. So let's look at number 1. Solve for y in the following triangle. So our question mark is this y value, okay, found here. Now, if it's found here, we have to ask ourselves, okay, what are we given, what do we need, and how do we solve for it? Well, the first thing you want to do anytime you're given a triangle, see that it's a right triangle, and find the hypotenuse. So remember, hypotenuse is opposite of that 90 degrees. So that means in this case, this 15 is the hypotenuse. Okay. Now, notice we are given the hypotenuse. We're given an angle. Now, what is y in terms of that angle? Well, if you're looking at it in the perspective of this angle, y is opposite. Okay. So we got to think, am I using sine, am I using cos, or am I using tan? Okay, and that I shouldn't have written cos, I should have written ka. So ka toa. Okay, so remember, this is like a way to memorize these formulas. Now, in this case, we're given opposite and hypotenuse. We're given the opposite and the hypotenuse. What relates opposite and hypotenuse? Well, that would be our first one. We have opposite, or we're trying to solve for opposite. We have hypotenuse. So a way you can do this is check mark things. So our opposite in this case would be the question mark. Our hypotenuse we have, and sine we have. If you have only one thing unknown in an equation, you can always solve for it. So it looks like we're going to use sine. If you look here, we don't have adjacent, and we have cos, and we have the angle, but we're not trying to find adjacent. right? We're trying to find y. If we were trying to find adjacent, we'd be trying to find this. But we don't care about this, so cos isn't what we're going to use here. Okay? So if we write out our sine formula, we know that sine equals opposite over hypotenuse. Okay? So sine equals opposite over hypotenuse. And now from here we can solve for, well, what do we solve? Let's plug in our values here. So recognize our angle is sine 57. Okay. And that equals, well, what is y? Y is the opposite side length. So y on top and our hypotenuse is 15. Okay. So now we have sine 57 equals y over 15. We can now solve for y pretty easily here. Y is already on top, so we don't have to manipulate. We just have to multiply both sides by 15 over 1 to get rid of 15, because now we have 15 dividing 15. And we get 15 multiplying sine 57. And what does that equal? So remember, you should be practicing how to plug these in your calculator, because that can sometimes be the most difficult part of this. But if we make sure you're in degree mode, so press mode and make sure that you're in degree mode, we can see for myself here, if you look here, okay, I am in degree mode. Now, I need to do 15, and I'm just doing normal sine because what I'm putting inside there is the angle. Okay, and that gives me y equaling, and I'm going to round it to the nearest unit. So this will be 12.58. And I'm rounding it to the nearest unit. So that means no decimal place. So that gives me 13. Okay, because the number beside 12, which is 5 or greater, which is going to round this up to 13. So y equals 13. Okay. So again, copy it down. Make sure you come ask questions if you're a little confused. Move on to example 2 here. So given the triangle DGB, where G is a right angle, determine the side length of GB and BD if D to G equals 45 centimeters. So that is a bunch of mumbo jumbo. Okay? So let's create what this triangle looks like. So we know it's a right angle triangle, so let's draw just a right angle triangle. And now we can start manipulating it. So it's saying that G has to be the right angle. So that automatically makes this G. Okay. And now D and B can be either one, right? Because you can read it as D to G to B. Okay. What else did they give us? They told us that D to G is 45 centimeters. So D to G is 45 centimeters. And it wants us to find both our angle, or determine the side length of G to B as well as B to D. Okay? Now, I'm noticing here that I actually forgot to give you an angle to work with. So let's say angle B equals 30 degrees. Okay, so that's a part of this question. Just I forgot to write it into the question. So that is my bad. So we're going to act as if this was given in the question. Okay, so angle B equals 30 degrees. So let's write that here. Angle B equals 30 degrees. So it wants us to not only find D to B, but it wants us to find G to B. So before you start doing anything, what do I always suggest doing? First, locate your hypotenuse. So your hypotenuse is opposite of that 90-degree angle. So that makes D to B your hypotenuse. Okay. Since it's your hypotenuse, we can start solving for certain things. Okay. Let's solve for the hypotenuse first. Okay. So let's solve for hypotenuse. Which in this case is D to B. Okay, so remember, we have our SOHCAHTOA. So looking at what we're given, what are we given in terms of 30 degrees? So if you look at 30 degrees, you have an opposite leg and the hypotenuse. What relates an angle with opposite and hypotenuse? Well, if we look here, opposite and hypotenuse. So we're going to use sine angle. Okay, so sine angle equals opposite over hypotenuse. Let's write in what we're given. So our angle in this case is 30. We know the opposite, which is 45. And we're trying to find the hypotenuse, which is d to b. Okay, and now we can manipulate this. Remember, d to b is on the bottom, so we're going to need to get it to the top. So let's multiply both sides by db over 1. Okay, this cancels our db out. And this is going to be now db times sine 30 divided by 1. Remember, that 1 doesn't really do much, so it'll just be db multiplying by sine 30 equals 45. And now we can divide both sides by sine 30. Okay, and that's going to give us d to b equals 45 dividing sine 30. Okay, and we're going to plug that into our calculator. So 45 divided by regular sine, because we actually have the degree in there, and that's going to give us 90. Okay, so this equals 90. And it's measured in centimeters. So d to b equals 90 centimeters. So we now have our hypotenuse. Okay, so let's kind of section this off because we're done there. So we found d to b, and remember that d to b can also just be represented as bd, so these are interchangeable. So we're done that. Now we need to find g to b. Okay, there are multiple ways to solve for g to b. Okay, so find g to b. There are multiple ways to find, this guy here, g to b. Okay, you could use either Pythagoras or you can use the ratios. Okay, I'm going to practice using ratios here. I'll probably end up showing you both anyways. Okay, so looking here, again, we're given an angle. We're trying to solve for this length, and now we have two known lengths. Okay, what I'm going to do is I'm going to try and use my 90 here. Okay, my 90 is my hypotenuse. I have a hypotenuse. Now, in terms of 30 degrees, what is g to b? Well, g to b is the adjacent side length, adjacent to 30 degrees. Okay, remember, hypotenuse can never be adjacent. It can only be hypotenuse. So that makes g to b have to be adjacent. So, which ratio should I use? Again, I have hypotenuse and I have adjacent. So, adjacent hypotenuse. So I'm going to have to use cos because it relates the two things. So cos angle equals adjacent over hypotenuse. Okay, and now we can plug it in. We're doing it in terms of 30 degrees. Okay, and our adjacent side length is g to b, and our hypotenuse in this case is 90. And now we can solve for g to b. In this case, we have to get 90 over to the other side, so I'm going to multiply both sides by 90. Okay, that cancels out, and we end up getting 90 multiply cos 30. That equals g to b. So practice plugging this into your calculator. 90 multiplying, I'll put this in brackets, cos, should be cos 30 degrees. That's going to give you kind of an uglier number. So G to B equals 77.9 centimeters, and I'm just going to round it to the nearest centimeter. So I'm going to round that up to 78 centimeters. Round to nearest centimeter. Okay, so that's one way to use a ratio. Now again, could we have solved this a little differently? We absolutely could. We could have used Pythagoras. Okay, so we have a triangle here where we have 45 and we have 90, and we're trying to solve for G to B here. Recognize we could use technically Pythagoras. This is our hypotenuse, and remember hypotenuse always equals C. So if we write out this equation, a squared plus b squared equals c squared, the main thing that's important is that you write your hypotenuse as C. So if we want to write this, we could write this as 45 squared plus b squared equals 90 squared. And then you could solve for our unknown value, which in this case is b. Okay, so if we plug in 45, now remember, where's that square button? The square button is found right there. You just press this button and it'll square it. So you get 2025 plus b squared, 90 squared, gives me 8100. Okay, we're going to subtract both sides by 2025. Cancel that guy out. So b squared equals 6075, and we're not quite done because we got a square root. Okay, in order to square root here, we're going to square root both sides to get rid of that square. And that's going to leave us with b equaling, and remember, how do you get to square? Well, it is the yellow button, or sorry, it is the yellow portion of x squared. So if you look at x squared, the one I'm pressing here, okay, if you look at x squared, there's a little yellow square root. So in order to get the yellow, you got to press second yellow, or second square, and then plug in 6075. And if you notice, it gives us the exact same solution. So 77.9, and we're going to round that to 78 centimeters. Okay, so just like we got up here, just a different way to solve for it. Okay. So make sure you take all that down, show your work, ask questions. Okay, so we got two more questions to kind of look at and practice. So let's look at this guy here. Determine the dimensions of this rectangle to the nearest tenth of a centimeter, where length of the diagonal, L equals 2.4 centimeters, and the given angle A is 25 degrees. So let's write that all out here. So let's make this look a little nicer. This is 25 degrees, and L equals 2.4. Now it wants us to determine the dimensions of this rectangle. Okay, so it essentially wants us, if we want to label these things, it wants us to find this length here, which I'm going to make X, and this length here. Well, let's not use X, let's use width. So let's use a W, and this as L, which is the length. Okay, now recognize they gave us this diagonal, which is what L is. So maybe we actually shouldn't have used L. So sometimes you got to practice and make sure you're putting the right variables. So I'm going to make this height, which works as well. So I'm going to make it H. Reason I'm not using L is because L was already taken. Okay, so you have the power to decide what to notate certain things. Now recognize we are given a triangle, a right triangle. Okay, so we have a right triangle here. So let's take that triangle out and focus on it. So if we look at this triangle, what do we know about it? Well, we know this is 25 degrees. We know that this is a right angle, so it's a right triangle. And then we know here L equals 2.4, and it's in centimeters. Okay. Now, if you look, this height here, is the exact same length as here. So that means this would be h. So from here to here is h. And hopefully we can see that this width here is the exact same as this width here. So this is w. Now, we're trying to find h and w. We're given a triangle. We have an angle that is not 90 degrees, and we have this length. Now, what is this length in terms of this triangle? Remember, we have our 90 degree, and it's across from the 90 degree, meaning that this thing is your hypotenuse. Okay? So, let's think about it. So, ka, toa. In terms of our 25 degrees, what is w? Well, w would be opposite. H would be adjacent. Remember, hypotenuse can never be adjacent. Okay? So it looks like we can use one of these guys to solve. Let's find h, let's find h first. So looking at this, we're looking for adjacent and we have hypotenuse. So won't work because that's finding opposite. Ka, we have hypotenuse and we're trying to find adjacent. So it looks like we're going to use cos. Cos angle equals adjacent over hypotenuse. So here we're going to do cos 25. The hypotenuse here, the adjacent is what we're looking for. Adjacent equals h. So I'm going to represent that as h. And my hypotenuse is 2.4 centimeters. And now you can see we can start solving for the hypotenuse. We have 2.4 centimeters in the denominator, so I'm going to multiply both sides by 2.4 centimeters. And that's going to cancel out 2.4. Remember, you can technically see this as over 1 if that helps you visualize what's happening a little better. So it looks like h is going to equal 2.4 centimeters multiplying cos 25. Okay, let's plug that in. So 2.4 multiplied by cos 25. And that gives me 2.1751 centimeters. And does it tell us to round it to anything? It does. So always check if it tells us what to round to the nearest tenth of a centimeter. So the tenth is the 1 decimal place. So it's 2.2 because the number beside it is 5 or greater, 2.2 centimeters. That's what h is. Okay? And you can kind of check your answer. Remember, hypotenuse is the longest length in a right triangle, so that means h has to be a little smaller. Okay? Now, how do we find w? Okay, so we could put here h equals 2.2 centimeters. Now, how do we find w? Again, just like the above question, we could either use one of our ratios or we could use Pythagoras because now we have 2 side lengths of a given right triangle. Okay, I'm going to practice using sine. Okay, so if we look here, opposite, that's what w is. So we're trying to find the opposite side length and we're given either hypotenuse or adjacent. I'm going to actually use TOA. So I'm going to use tan because we're trying to find the opposite and we have the adjacent side length. So let's find w. And in this case, I'm going to use tan angle equals TOA opposite over adjacent. Okay. And now here we can plug this in as tan 25 And what is the opposite side length? That is W. That's the thing we're looking for. Adjacent is our 2.2. Now, this is something super important to recognize. I am not going to use the rounded value 2.2. I'm going to use the more accurate value, and I'm going to use a few decimal places. So if you look up here, I'm actually going to use and try and use all those decimal places. So 2.175138689. Okay, so recognize I'm using that whole number. Okay, and now I'm going to solve for W. Now, why do I do that? I do that because if you use the rounded number, you are going to get a wrong number possibly. So in order to solve for W, W is being divided by 2.175, blah, blah, blah. So I'm going to multiply both sides by 2.175138689. Remember, that's technically over 1. Okay, and maybe I'll give us a little bit of room here because it's a big number. So I'll multiply this side by 2.175138689. Okay, and that cancels out. So what does W equal? When I plug this in, now here's a trick with your calculator. Whatever answer you plugged in last, okay? So my last answer was 2.17513. If you look at the negative symbol on the very bottom row, so right here, you can see me pressing it, okay? There's a little value there that says ants. Oh, what does that word mean? So I'm going to delete all this. If you press second ants, okay, see how that ants popped up there? That means the last answer you just got. So my last answer was 2.175, blah, blah, blah. And now, what are we doing with 2.17? That's what ants equals at the moment. I'm going to multiply ants by 1025. Oh, whoops. Oh, yeah. And that gives us what W is, 1.014 centimeters. Remember, it asked us to round it to a tenth. So that means we have to round it to the 1 decimal place and recognize 1, the 1 to the right of it, is lower than 5. So we're just going to leave it at 1.0 centimeters. And there's W. So we found the dimensions of this. It would be, this rectangle would be a 2.2 by 1.1 centimeter rectangle. Okay, so that calculator trick I just showed you with that ants, super useful. Practice it. So if I do 8 times 3 divided by 2 plus 4, that gave us a really nice number. If I go 8 divided by 3 plus 7 divided by 2, 6. Let's go something where I know I'm going to get a really ugly number. There we go. So if I get 16, and that was the last thing I did, and I had to do something with that number, maybe I need to do this. Maybe I need to go 4 multiplying 6.4012 plus 3. How do I do that? If I didn't want to round this number, I would go 4, second answer. So now that answer is what you just got. So it's pretty much showing this, okay, plus 3. And that would give us a more accurate solution. So practice using the ants button. That goes a long way in science too, as well as harder math courses. Okay, let's do one more here. Example 4. So remember, with word problems, label, list, and determine what value you need. So a 6-meter long ladder leans against a building. If the ladder makes an angle of 60 degrees with the ground, how far up the wall does the ladder reach? How far from the wall is the base of the ladder? Round your answers to 2 decimal places as needed. Okay, so let's draw this. So we have a ladder and it's leaning against a wall. So here's our wall. And we're going to draw our ladder like this. Okay, if the ladder makes 60 degrees with the ground, that would be here. Okay, and remember, this is a 6 meter long ladder. So that means this ladder is 6 meters. Okay, now my questions are, how far up the wall does the ladder reach? Okay, so we're wondering this, the height. And we're also wondering how far from the wall is the base of the ladder. So this. And we're going to make this, we're just going to make it x. Okay, so h is our question mark, and so is our x. We could further simplify this by just drawing this as a regular right triangle, with this being 6 meters, this being x, and this being h. So look it, we went from a fairly confusing, lots of words, lots of information, to a nice diagram, and then to the most simple triangle you can get. And you know how to solve this at this point. This is 90 degrees, and this is 60 degrees. And from there, it shouldn't take too much to solve, okay? Now remember, anytime you're given a right triangle, the first thing you want to do is determine where's your hypotenuse. Okay, so you have 90 degrees here, and opposite of that is your hypotenuse. So this is your hypotenuse. So we have our hypotenuse, and now look at the angle you're given. In the perspective of this angle, where is the opposite side length? That would be h. So opposite to 60 is h, so this is opposite. The adjacent would then be x, because remember, hypotenuse can never be adjacent. So here, let's solve for x. How do we find x? Well, let's go through SOHCAHTOA. We're given hypotenuse, we're finding adjacent. What relates hypotenuse and adjacent? Adjacent hypotenuse, so it's going to be cos. So cos angle equals adjacent over hypotenuse. And now we can plug those in. Cos 60 equals adjacent is our x, and our hypotenuse is our 6. Adjacent is our x, hypotenuse is our 6. And now we're just simply solving for x. Multiply both sides by 6 over 1, or simply 6. This helps us cancel out our 6, so we get 6 cos 60 equaling x. So plug that into your calculator. Now we get x equaling 3. Okay, so now we have x equaling 3, and now it's our job to find h. You could use sine, because you're trying to find opposite and you have hypotenuse. You could even use TOA, because you have the adjacent and you're finding opposite, or you could use Pythagoras. Okay, I'm going to use Pythagoras, just to remind us. Okay, so a squared plus b squared equals c squared. Now remember, the main important thing with this equation, that c has to be hypotenuse. So this is c. So this is going to be 6 squared. And remember, a and b are interchangeable. So 3 could either be a or b. 3 could either be a or b. So let's make b 3. And now we're going to solve for a, which in this case would be h. Okay, because that's what we're trying to find. So maybe I'll actually make this h here, h squared. So 3 squared is 9. 6 squared is 36. Remember, you have a square button right there, so 6 squared is 36. And then we can subtract 9 from both sides. And we can square root. So remember, how do you square root in your calculator? You square root using your second button, because squaring is found right where the x squared button is, but it's in yellow. So yellow button squared, 25, and hopefully you know that's 5. Now what's the units here? The units are, let's see, the units would be meters. So this actually should have been given meters there. So 3 meters. And height is 3 meters. Okay, so I would suggest trying to find h using cos angle and tan angle. You're going to get the exact same solution, okay? Other than that, guys, that is 2.5. So lots of information there. So make sure you take all your notes down, rewatch portions that maybe you didn't understand, and if things just aren't sticking, please come see me. I love when students come ask questions, and there we can even dive a little deeper, okay? This is essentially just to get you started with the unit, okay? And then moving forward, if you come and talk to me, we can figure out how do I get like 90s in this course. If you just watch these videos, you can kind of hope for maybe about 70 if you work really hard, 80 possibly if things are just making sense. But if you want really high marks, you always want to come talk to me, because then we can talk about more difficult concepts together. But other than that, I'd go check your understanding right now, go to 2.5 AFL, and give it a shot, see what makes sense. If things are not